Addfor is a company based in Turin, specialized in applying artificial intelligence and engineering, integrating for today's application for industry, defense, automotive, and they supply the world's most known automotive brand for sport and car and racing. Addfor selected some demonstration that show what they've been doing in Turin in occasion of the problem we had recently with the virus. They had a collaboration with the local police in order to put their software on drones and monitor the safety condition of the people in the parks, in the public area. On top of that, we will see later on how we've been digitalizing the area in Modena, creating some scenarios that are validated for virtual development based on Modena town streets, town center streets, different areas, and some highway parts. But let's see what they're going to show us.
As part of the Torino City Love Initiative, Addfor and the local police started a collaboration to help in fighting the COVID pandemic. This collaboration is about using drones to patrol and monitor the city parks. This activity has been developed in collaboration with the Digital Investigation Department of the local police of Turin, and in particular with the collaboration of the Chief Commissioner Gianfranco Tedesco. My name is Enrico Busto, and I am the founder and Chief Technical Director in Addfor. Our mission is to provide the most advanced artificial intelligence solution for automotive manufacturing, monitoring, and security application. For more information, you can contact me on LinkedIn or by email with the reference you find below.
We have decided to integrate drone patrolling with artificial intelligence and to introduce autonomous drones in the future. This action will strengthen public safety and security within parks, green area, and other urban spaces.
Artificial intelligence analyzing real-time the video streams coming from the drone, performs the analysis and the detection, and saves the data in the database. The data are used immediately to treat the action of the local police and, at the same time, are stored to be used by the city council and the public administration at any level to make informed decisions on how to manage the city. The starting point is the mission planning. In this case, we use DJI drones, and we plan the mission with the DJI dedicated software that is called Flight Hub Enterprise. The Flight Hub Enterprise allows the user to stream images and video together with the telemetry data to an external application, and this is exactly what we need to integrate the artificial intelligence systems. Once the mission has been planned, we are ready to fly. ENAC, the Italian Civil Aviation Authority, granted special permit for this activity, allowing drones to fly over the city parks. Over 140 flying missions have been accomplished over the past few weeks, for a total of 48 actual flying hours, mainly on 3 city parks, Colletta, Carrara, and Valentino. Here we show you the images taken while flying on the Valentino Park, maybe one of the most beautiful in Turin, located around the river Po banks. A total of 1.7 million square meters of park area have been monitored. Artificial intelligence. We use artificial intelligence to analyze the video streams coming from the drones and detect people, vehicles, and any other object when requested. The detection are corrected in perspective, and the position on the ground is calculated. Since the drones are using 4K cameras, we can detect people even from distance and from high altitude. This is particularly important in the COVID phase 2, since the people are allowed to go to the city park for outdoor activities, but the recommended social distancing should be maintained at any time. Those artificial intelligence algorithms calculate the interpersonal distance between people in real time and raise warnings in case the safety measures are violated. The dashboard. All the data are available in real time and can be stored in database to help in making decisions at commission level. But since the data are available in real time, it can be used to trigger immediate police response. like in this case where two cyclists were caught in a city park during the lockdown. 3D mapping. Furthermore, the data collected can be used for alternative purposes, however, great importance for the municipality. For example, drone video streams can be used to create high-definition 3D maps of the area overflown, like in this case.
The aim of computer vision is to simulate the functionality of human eyes and brain components responsible for the sense of sight. Doing actions such as recognizing an animal, describing a view, or distinguishing among visible objects in an image or also in the real world are intuitive tasks for humans, and for this reason we fail to appreciate the key challenges that are involved when we try to design systems similar to our eyes. We unconsciously detect objects, and so it is difficult to understand the entire process to train a neural network. To train a neural network, a very large amount of images with the relative ground truth is necessary. And producing this ground truth means facing with the process of assigning a label to each element of the image, or even to each single pixel if we are training a neural network for semantic segmentation. So all images of the dataset, of the training dataset, have to be manually processed, and humans have to draw or at least verify and correct labels or segmentation masks. And this is an extremely expensive and time-consuming process, and commonly it is considered to be not worth the effort. Moreover, the requirement of obtaining a neural network that is able to recognize entities in real conditions, so for example in different weather conditions, different lighting conditions, or an environment that can be various with different characteristics, makes mandatory the heterogeneity and the variability of the training set of images. And this means that if we want to obtain a suitable dataset, we have to collect many images with a large number of characteristics, weather conditions, lighting conditions, and so on. And capturing enough images in the real world and then labeling them, it is an extremely expensive and time-consuming process. So synthetic data can be an alternative solution to replace or integrate real data, and can reduce the problems of costs and waste of time. Obviously, other problems arise, and the most relevant concerns the problem of domain transfer. This means that the synthetic images do not look exactly like real images, even if the larger part of the literature reports that the synthetic images should be as photorealistic as possible. In this sense, laser scan can be employed to acquire portions of the real world, producing 3D environments that have a high level of realism. And these environments can be used to generate synthetic datasets that are suitable to train neural networks. We used a laser scan platform to acquire some areas of the city of Modena. The use platform is equipped with several laser scanners and with a set of 6 cameras. The point cloud was used to model the meshes of the objects in the synthetic scenario and all the geometries in the environment. The images have been used to generate the textures and then the materials of the 3D objects. This technique ensures high level of photorealism, and the 3D environment can be used to exploit all the advantages of working with the synthetic navigable space. It is possible to automatically obtain the ground truth of the rendered frames by replacing the realistic material with monochromatic materials, and it is also possible to change weather and light conditions, or to add the specific elements to better characterize the situation, or to represent critical situations such as a pedestrian or a generic obstacle in the car trajectory. Moreover, it is also possible to add a number of virtual cameras and to change many times the point of view.
This concludes our presentation. Thank you very much for your attention, and don't forget to contact us if you need more information.